Good morning. We have a Wee number theory problem, which we will work on this morning. And if you're watching this in the replay and you haven't tried it yet, I encourage you to do that. Let's get to it. Okay, I'm gonna share the. No, not that one. Do that one. Yeah. Okay. So what are we looking for? It is. Let me just enlarge this on my end here. Okay. So what we want to do is we want to show that we've got P is a prime number greater than 3. So we want to show that if that's the case, so that implies that P squared, so the square of that prime, is congruent to 1 mod 24. Okay. So if P is prime greater than 3, then P squared is congruent to 1 modulo 4, 1 mod 24, sorry. So let's rewrite this. What we're saying is that P squared minus 1 divided by 24 is an integer. And let's go a little bit further with that, because if P squared is if P is a prime greater than 3, we can safely say that this is all positive. So let's just add that proviso, quid pro quo, Latin stuff. So what do we want to do? We want to show that 24 will go into P squared minus 1. Okay, so let's write that again over here, P squared minus 1, but let's split up 24 into its prime, elements here. Okay, so it's 2 cubed times 3, there's P squared minus 1. Hello, Risha. Greetings, thanks for joining us. Let's see here. Okay, so each of these, okay, it's not sufficient for only one from each prime factor to go into P squared minus 1. Each one needs to be represented. Okay, and so I'm going to actually rewrite this because I know what's coming. Okay, as 4 times 2 times 3. And the reason why I'm splitting it up that way will become apparent very soon. So this P squared minus 1, let's just, I hate it when people say just. Let's factor that, and I'm going to keep everything down here because there's not like a lot going on here, so I could rewrite everything so we can follow it along. So we factored that into P plus 1, P minus 1. Okay, that's your factorization of P squared minus 1. And now I'm going to create a number line with P right here in the middle. And what's the number just before P in the integers? It's going to be P minus 1. And what's the number just after P in the integers? That's going to be P plus 1. So we've got a string of 3 consecutive integers in P minus 1, P, and P plus 1. Now, what do we know about these guys? Well, we know that P has got to be odd, okay? Because it's a prime number. It's greater than 3. 2 is the only even prime number. So P is odd. So that means P minus 1 has got to be even. Okay. P minus and P plus 1 has also got to be even. Okay, meaning P is odd. We already determined that. Okay, so now let's look at factors. Let's write some factors up here. These numbers both have 2 as a factor. Now, numbers with 4 as a factor, it's every other even number. So either P minus 1 has got a factor of 4, or P plus 1 has got a factor of 4. So what do we have here? We know that one of these, either P minus 1 or P plus 1, has got a factor of 2. And the other one has got a factor of 4. So now all we need to do is determine, does 3 go into any of either of these? Okay, well, 3 won't go into the prime number because by definition, P doesn't have any factors other than 1 and itself. And up here, we already decided that P is not 3 because it's greater than 3. Okay, but if you have a string of 3 integers, guaranteed 3 will be a factor of one of them, because just as the even integers alternate, even odd, even odd, even odd, with the divisible by 3 integers, you've got 1 divisible by 3, 2 not. 1 divisible by 3, 2 not. So one of these 3 is going to be divisible by 3, but we know it's not the prime, which again, so we know that it's going to be this one or this one. And do we have any way of determining which is which compared to the 4? We don't care, because now we've established that 3 is a factor. So all of the factors of 24 divide into P squared minus 1. Okay, so that means that 24 divides into P squared minus 1, but that is the same as saying that P squared is congruent to 1 modulo 4. And let me just conclude that with a statement. Bob's your uncle. Why did I put an S there? Oh, maybe because more than one of you has an Uncle Bob. And that concludes the brief, I said it would be brief, number theory problem. Thank you for joining us. We're going to sign off right away, and cheers.